Okay, so given this diagram, what is the ratio of A theta, right? A at theta and B at theta. So if this is theta, okay, if this is theta, so the radius, right, this is a semicircle. Let's cut it in half, which means this is going to be theta over 2. R, right, R is going to equal to 10 sine of theta over 2. Okay, which means A theta is going to be half of pi r squared. Okay, so if you square that, you get 100 sine squared theta over 2. So 50 pi, like that. As for this, right, this height here, the height is actually equal to 10 cosine of theta over 2. Okay, cosine of theta over 2. So the area of the triangle, so B, for the bracket here, B theta is going to be this 2r, so 2 times this, which is 20 times by sine of theta over 2, times by this, okay, and times by half, because this is a triangle. So we get 10 times 10, which is 100 sine of theta over 2, and cosine theta over 2. Okay, so I would like it in terms of just theta instead of theta over 2. So this one here can be written as 50 times by 2 times this. So I can use double angle formula to write that as sine of simply theta. For this, recall that cosine of 2 theta is equal to 1 minus sine square theta. So sine of square theta is going to be 1 minus cosine of 2 theta. So if you replace that with theta over 2, right? Theta over 2, you're going to get 50 pi. You're going to get, forgot the 2 here, sorry. So 2, so you got to divide this by 2. So I'm going to get a 1 minus cosine of theta over 2. Okay, which means it's equal to, right, 25 pi 1 minus cosine of theta. Okay. So that means this right here is going to be 25 pi 1 minus cosine of theta over 50, right, sine of theta. We saw in the previous questions that the limit of this as theta approaches to 0 is going to equal to 0, right? You can use the conjugate pair technique. Okay, so the numerator becomes minus sine, actually the positive sine square theta. So that will make the whole thing equal to 0. So therefore, this limit is equal to 0.